I'm Joel Morwood. I'm from the Center for Sacred Sciences, and I'm very honored to be here. I'm also humbled to be here because it's a conference of science and non-duality, and we have real scientists in the room, and I'm not a scientist. I couldn't solve a differential equation if my life depended on it. I'm hoping that I can give you a new way to look at science as a whole. I have nothing to contribute to science, but maybe I can frame a way of looking at science from a mystic's perspective. So, what do the mystics say? What the mystics claim is that the ultimate nature of reality is non-dual. And more specifically, that distinctions, all distinctions are imaginary. And you'll find this testimony given in the mystics of all the great traditions. Let me just read you a couple of short little ones to tune us in. Here's the great Christian mystic Meister Eckhart. If we will see things truly, they are strangers to everything that tolerates any distinction, be it in a thought or in a name. They are intimates of the one that is bare of any kind of multiplicity or distinction. And specifically what mystics are concerned about is this distinction between subject and object, I and other, self and world. They all claim that that distinction is imaginary. It isn't really there. Here's the great Hindu mystic Lalishwari, and here's what she says. When the mirror of my mind became clear, I realized the fundamental principle, and this non-dual knowledge completely destroyed all thought of you and I. And the great Tibetan master Longchenpa, he agrees. Aho! In the perception which is natural and pure from the beginning arises the wonderful intrinsic awareness that makes one laugh. There is no duality between mind and its object. And then one last one, Rumi, the great Sufi poet, sums this up by saying, I sought round the world for others and reached certainty. There are no others. So this is the non-dual wisdom of the mystics of all these traditions. And there are some of us here, maybe most of us here, who would like to make this non-dual wisdom the cornerstone of a new worldview. Is there anybody who doesn't want to? Okay. But here's the problem. We're facing one problem. Because we do live in a scientific age, an obstacle we have to overcome. And I think Einstein, the great physicist, sums it up very succinctly. And here's what Einstein says. The belief in an external world independent of the perceiving subject is the basis of all natural science. Whoa, let me read that again. This is Einstein now. The belief in an external world independent of the perceiving subject is the basis of all natural science. So he's directly contradicting the testimony of the mystics. He's saying, actually, the distinction between self and world is very real, and there is a world out there of physical objects and so forth that exists independently of our minds, our consciousness. And there are many people in the world today who, like Einstein, believe in this materialist or physical realist worldview. They believe in the materialist worldview because they believe it explains why science works. Science works, science comes up with physical theories, and the physical theories work because they match a physical world that exists out there. Very simple. Now, so here's the problem. If the materialists are wrong and the mystics are right, why does science work? Or we could put it more formally by saying, can we explain the efficacy of science from a non-dual perspective? So this afternoon, I want to sketch for you, and I mean just a sketch, of an answer being explored by myself and a colleague at the Center for Sacred Sciences named Tom McFarland, who does have a background, fortunately, in physics and mathematics. Otherwise, I'd be way out here on a limb. I'm already far enough as it is. And I want to just present this to you. And as I say, this is kind of a work in progress, but hopefully it'll spark some interest and some your thoughts and your ideas and whatnot. So let's plunge right in. Let's begin by taking a closer look at what the mystics mean by non-duality. And let's look at what they say about the fact that, to most of us anyway, the world does appear to be dualistic. We appear to be separate selves wandering around in a universe of objects out there. So how does that appearance come about? So here's the answer given by the Taoist Chung Tzu. A road is formed where there was none before, merely by people walking constantly upon it. Likewise, the things are formed by their being designated by this or that particular name. In other words, our language and our thoughts creates distinctions. And we superimpose those distinctions onto non-dual reality, and so it appears the distinctions appear to exist in the reality, and we have a world full of separate things. We can illustrate this very simply in our own experience. I name this thing glasses. I create an imaginary boundary around it which separates it from everything that is not glasses. So already I have duality. I don't even have to name anything else. There's just glasses and everything that's not glasses. And of course, if I start naming everything else, I end up with not just duality, but multiplicity. This is why Shankara, the great Hindu mystic, writes of Brahman. Brahman is the Hindu name for the ultimate non-dual reality. No matter what a deluded man may think he is perceiving, he is really seeing Brahman and nothing else but Brahman. He sees Brahman and imagines that it is the universe. But this universe, which is superimposed upon Brahman, is nothing but a name. So he's saying the same thing that Chung Tzu said. Somehow this appearance, this illusion comes from our thought and then our language, and then behind that our thought. Rumi agrees. Here's what Rumi says. That oneness is on the other side of descriptions. Nothing but duality enters speech's playing field. That's a beautiful way to put it. Nothing but duality enters speech's playing field. Every time we speak, we open our mouths, we are in a sense creating duality. Which just incidentally is why mystics are always insisting if you want a direct realization of this non-dual reality, you have to get beyond thoughts and speech and all that. But let's be very clear about this. There's nothing wrong with creating distinctions. That, in fact, is the function of language and thought. And they are extremely useful. And not only are they extremely useful, they're beautiful. Rumi's poetry is full of distinctions. And we have stories and lyrics, songs and dramas and all that's all distinctions, the play of distinctions. So that's not the problem. Even superimposing these distinctions onto non-dual reality is not the problem. In fact, that's what gives us the play. It's when we start to take these distinctions to be real. We reify these distinctions. And that's where we fall into what the mystics call delusion. And that's what causes us to feel like we are separate selves banging around in a universe of solid objects out there. And we can get some idea of this indirectly through a comparison of different worldviews. Any of you who have studied anthropology are very familiar with this kind of material. But really, people who hold different worldviews live in different worlds. And I'll give you one very quick, short example. I only have time for one quick, short examples in these things, but it's a quite cogent example that illustrates this business about distinctions. There was a Norwegian explorer at the turn of the 20th century named Knud Rasmussen who traveled up in the Arctic regions. And he met an Eskimo shaman who explained to him how he acquired a spirit helper. And his name was Ayua. And Ayua was out there in the Arctic waters. He was fishing in his kayak, and a shark swam up next to him. And the shark called his name. And Ayua was greatly astonished because the shark was way out of its normal waters. Now, first of all, it's interesting. Ayua is not astonished by the fact that a shark called his name. Because in that world, in that worldview, sharks can call your name. You can communicate with animals. That's not so weird. But just that the shark was, way out of its normal cruising range. That was weird. Now, so first of all, this gives you a little, what do you guys, like psychologists call this, cognitive dissonance, and then, but there's something very instructive about this. I bet you a lot of you have had actually a similar experience. You're walking along in the evening, there's some breeze blowing, and suddenly you hear jolt, and you look up, and there's a big old crow sitting on a branch looking at you. And for a moment, it passes through your mind, did that crow call my name? And you go, no, it's just my imagination, it was the wind or something, and you walk on. Now notice what's happening here. You're drawing the line, the boundary between self and world to include the voice calling your name. You're saying it's on the inside of the boundary, you're attributing it to your imagination, and so you ignore it because you don't have any value to your imagination. That's too bad about us Westerners to begin with. But nevertheless, it affects your behavior. You walk on. Ayua draws the boundary to exclude the name, so it's coming from outside the self, and he attributes to the shark, and they develop a wonderful relationship, and the shark helps him with fishing and stuff like that. So it's where we draw the boundaries here that makes this huge difference in how we live our lives and behave and so forth. And it gives us a clue that these boundaries aren't fixed, that they are, in fact, imaginary, just as the mystics say. Okay. So then, what does all this have to do with science? In the pre-scientific worldviews, they explained the universe based on thoughts and language that drew boundaries in terms of animistic concepts or mythic concepts or religious concepts. And then about 500 years ago came a new way of envisioning the world we call science. And the thing that was different about science from all these other ways of envisioning the world is that technologically, science was far more successful. And I only mean technologically. I'm not saying spiritually more successful, psychologically more successful, ecologically more successful, but at a technological level, at a very practical level, I think there's very little question that science was superior. And again, I'll illustrate this one little report that I read recently from a man named Maurice Collis, who is a British civil servant serving in Burma in the 1930s, who witnessed a revolt of Burmese peasants against British rule. And these peasants came out and they attacked the British troops who were armed with guns and machine guns and even an airplane, and they attacked them holding up amulets and chanting spells and pointing their fingers at the plane, hoping it would fall out of the sky. The peasants lost, and the British won. And this incident has been repeated countless times over the last 300 years, which is why Western powers were able to dominate so much of the world for so long and until quite recently. And even today, why countries like Iran and China and so forth are scrambling to get this technological power for themselves. So this is all I mean. that it is technologically, suddenly there's this kind of leap forward, a way to manipulate phenomena that was phenomenal. So what is the materialist, physical realist explanation for this? Well, a materialist will say, back there, I'm sure you had this in your history of science class, if you took one or just history, or just picked it up through osmosis. Back there in ancient Greece, some natural philosophers started to explain the world in using models, physical models, or in theories, rather than animistic or mythic, to explain how things worked. And then somewhere in the 17th century, the early scientists began to formulate these physical theories into a mathematical language because it was more precise and more convenient. And they also started testing these theories against observation and experiment. In other words, they invented the scientific method. And so as science became more refined, as the physical theories became more refined, they matched the real physical world out there more and more, and so it became possible to produce these more and more technology from that fit. So I think we've all heard that materialist explanation. But let's look at a couple of things about this. First, the assumption is here, because something works, it must reflect reality. And that ain't necessarily so. Today, I can get a little sailboat down in the bay there. If I'm armed with a sextant, a compass, a seagoing clock, I can sail all over the globe using Ptolemaic astronomy, an Earth-centered astronomy. So I can shoot the sun as it rises over the horizon, the moons. I can tell where I am by the constellations going around the Earth and all that. It works great. Doesn't mean we assume that it reflects the nature of reality. In fact, today we assume it doesn't. It's wrong. But more importantly, from a mystic's point of view, is this role of mathematics. Because in the materialist account of mathematics, of science, the development of science, mathematics plays a passive role. It's a very convenient way to describe the physical models, the theories, and also to describe the relationships between these objective facts out there. But what if that is not the case? What if mathematics doesn't just describe the facts, but actually creates the facts? And what if that is the key to science's success, rather than having anything to do with physical theories matching or reflecting some physical reality out there? So, let's take a closer look at mathematics. All languages create distinctions, and the natural languages, as we might call them, English and Chinese and whatever, Navajo, create primarily qualitative distinctions. And we can see this even in the physical theories of the natural philosophers of Greece. For instance, Aristotle conceived of at least the terrestrial world as being made up of qualities: hot and cold, wet and dry, and these combine to form the four elements: earth, air, wind and fire, or water and fire. These are the building blocks of Aristotle's universe there. Now, these are qualitative distinctions. They're not precise quantitative distinctions. But mathematics allows us to create precise quantitative distinctions. This is the big difference between mathematics and these natural languages, and the big difference between science and all pre-scientific worldviews is that science speaks the language of mathematics. And if we look at history, we see that every advance in science is preceded by an advance in mathematics. So, for instance, the Greek astronomers made advances over the Babylonian astronomy because they invented trigonometry. Newton had to invent calculus in order to express classical mechanics. And relativity depends on non-Euclidean geometry, which was invented years earlier by pure mathematicians who didn't think it had anything to do with the real world. So what we see here is a language. Mathematics is getting more robust, richer, and as it does, science starts really progressing. Science takes off. But it's not just the theories. It's the mathematization of the observation and experiment through increasing use of calibrated instruments. So we have, we start with simple astrolabes. We have quadrants, sextants. We start with sundials. We end up with atomic clocks. We have thermometers, pressure gauges, all this stuff. These instruments are actually imposing a mathematical grid on the world, and we're seeing the world through that grid. And what these instruments are measuring are mathematically defined properties. Units of time, of space, mass, charge, all these things. Units which actually, we have to remember, are imaginary. This paper here is 8.5 by 11 inches. Yeah, that's great. That's a fabulous thing. I can do all kinds of things with that information. I can make machines that will stamp out page after page of paper the exact same size and all this. But there are no inches in this paper. I can look, I can put it under a microscope, I can subject it to chemical analysis. I'm never going to find any inches. All these units are imaginary. We superimpose them upon the world. So, maybe the secret of science's success is not the physical theories. Maybe the secret is the language science speaks, mathematics. And actually, history shows us that at critical junctures, allegiance to physical theories has delayed the acceptance of mathematics, of the progress of mathematics. I'll give you 3 quick examples. One is back in the 2nd century, in the Common Era, when Ptolemy came up with his astronomy. And at that time, Aristotelian astronomy dominated the thinking of the time. And it was a qualitative astronomy. They looked up in the sky and they saw how all the stars moved, all coordinated around the pole star. And why they didn't fall to the earth was a question in itself. And how could you explain this? And so they envisioned a physical model was that they were all attached to a crystalline sphere. You can't see the sphere because it's like clear crystal, but they're all attached, and the sphere moves like this, and the earth is at the center. It explains it. It's beautiful, actually. Then there were a couple of problems. The problems were the planets. Some of these stars didn't follow this. They went on their own. Planet means wander. Well, they must be attached to crystalline spheres that move independently, that are within the great crystalline sphere of the fixed stars. And then the sun and the moon are on their own spheres and all that. So beautiful. This lasted over 1,000 years as the physical explanation of the heavens. Ptolemy came along and he noticed there were certain problems with this. One was the planets actually don't go around in these perfect circles. They go around, then they go back, they go around, they go back. How do you explain that? And so he came up with a geometry where the planets went around, then they go around a little circle on their own orbit. They go around, they'll go around a little circle, go around a little circle, and that explains why they look like in the sky they're going back, but they're all going in circles. So he preserved this geometric beauty of everything in the heavens having this circular motion, and it was far more accurate. You could mathematically predict where things were actually going to be in the sky. The trouble was it was impossible because these little circles, if the planets actually went in the little circles, they would crash into their own crystalline spheres. So Ptolemy himself rejected it as a view of reality and said, well, it's just a calculating device. Some of you have heard that before about quantum mechanics, right? Just a calculating device. And nobody seriously considered that it might be a clue to moving science forward until Copernicus came along. Second example, Newton. Newton unified terrestrial motion and celestial motion in a wonderful, amazing single theory. And at the heart of this theory is what's called the inverse square law. It's actually a mathematical equation. And this equation is the equation of gravity. It explains the force of gravity, how the proportions of the forces of gravity. And the whole thing hangs together with this. It's right at the heart of his classical mechanics. And he was criticized by the mechanists of his day for introducing spooky action at a distance, occult phenomena into his system. It's no physical explanation for why the Earth should be attracted to the sun and the sun to the Earth. It's weird. It's not a mechanical description. And Newton himself never offered a mechanical description. He always insisted, I don't know, but I know my mathematics works. And in fact, it works so well that people began to accept, well, maybe gravity is some sort of physical force. And then the last example I want to give is quantum mechanics. And I'm not going to really go into quantum mechanics at all because you're going to hear a lot about quantum mechanics at this conference. But at the heart of quantum mechanics is an equation, Schrodinger's equation. I've already heard about Schrodinger's equation. I've only been here a couple of hours, and you're going to hear much more about Schrodinger's equation, I'm sure. And then a whole mathematical formalism built around that. And here we are, I don't know when Schrodinger's equation was, 1927, I believe, something like that, close. Anyway, we're, getting on to 100 years, and to this day, there is no consensus among physicists about a physical interpretation for this mathematics. Now, this mathematics, there's never been more powerful mathematics ever. I read recently an estimate that 2/3 of the technology you and I use is based on quantum mechanics. This isn't some arcane, physics over here for specialists. This is fundamental to how we do things today. And yet there's no agreement on the physical interpretation. So, to sum up, what if all languages create distinctions, just like the mystics say? These distinctions are overlaid on a non-dual reality, which remains non-dual, by the way. Just because we overlay distinctions doesn't change that. That natural languages are primarily qualitative, so we get by with them. We can do an awful lot with them. But mathematics is quantitative. And science, it's the language of science, and that's why science has been so successful. It's allowed science to divide up the world in very precise, minuscule ways and reassemble it and put it back together. And so here we are. And I'm getting the wrap-up signal here. So I'm offering you that as a proposed answer to the question, why does science work? So let me just say this. If you are not satisfied, which of course you may well not be, I challenge you to come up to an answer to that question. Because if we want non-dual wisdom to become widespread and accepted, we have to answer that question. Otherwise, we are going to remain an elite group of people meeting at conferences like this, which I enjoy. You're all wonderful people and all that. But we are not going to make that quantum leap forward. So, are we out of time here? Okay. Any questions?
The distinctions, imaginary as they are also part of the non-dual reality.
Very good point. And you know what? As long as they're speaking words, we have to make distinctions.
Yes.
But ultimately, you're right. In fact, if we use the word non-dual, we still haven't said it because non-dual makes a distinction between non-duality and duality. So, if we really want to get beyond distinctions, we have to shut up. But I don't think we're going to do that at this conference.
But whatever that non-dual reality is, it produces imaginary distinctions.
Yes, it does, and it loves to. See, that's why I made a point of saying that. It's the play, the divine play. It's the Leela. Yeah. Our only problem is we take them to have a reality they don't actually have, a kind of reality.
Thank you.
Is that it?
Yep.
Okay. Thank you very much.